Okay, so we're working on these two problems, these two equations from chapter 2, and I gave you 5 steps the other day. First step was to distribute to remove any parentheses. So on this problem, you're going to go 5 times 2, 5 times 1, and you're going to get 10x plus 5 equals. On this one, you're going to go 10 times x, 10 times a half. Now, if you don't know what 10 times a half is in your head, go to your scratch paper and do it. Or go to your calculator and do it. 10 times a half. On your calculator, you could also go 10 times 0.5 if you remember that 1/2 and 0.5 are the same. Okay. The other thing is, how do you multiply? You turn this into a fraction, 10 over 1 times 1 over 2. And when you multiply fractions, you multiply top times top. 10 times 1 is 10. Bottom times bottom is 2. And then reduce. Whatever we get over here, this becomes 10x plus 5. Okay. Now, if you're looking at this and thinking about this, little bells and whistles should be going off in your head right about now. But let's continue with the steps because I want to show you something. We're supposed to get all of the x's on the same side. That was the next step. Okay, get x's on the same side. So I'm going to take away 10x here, but I have to do the same thing here. And when I do that, I end up with 5 equal 5. All of my x's dropped out. Okay, and this is I wrote the other day, this is a WTF problem. Something weird is happening. Okay, now leave some room here if you're copying my work. Leave some room because I want to come over and work on this one, because it's really important that we compare and contrast these two problems because they're closely related to each other. So I'm going to pause right here. 5 equals 5. The variable dropped out. Okay, so something's weird is happening. So let's come back over here. Same thing. Okay, there's nothing to do here, so we leave it as 3x minus 6 equals. We're going to distribute the 2 into here. So that's going to give me 2x plus 8 plus x. Okay, and then we're going to add, it was simplify each side. So if we add these together, this becomes 3x minus 6, but the right-hand side simplifies into 3x plus 8 because 2x and 1x make the 3x. Okay, again, our rule is get x's together on one side. So I'm going to take 3x away from this side, take 3x away from this side. And when I do, I get negative 6 equals 8. Again, this is a WTF. Okay. And if you don't know what that is, ask someone when we take a break. I can't tell you. All right. Some critical things here. Okay. First off, any questions about getting to this step on either problem? Any questions about my work, what I did, how I got to these steps? There's more to do, but I want to make sure you're not lost yet. Okay, now, critical ideas here. There are no x's. The x's dropped out. There are no x's. Okay, but this is true. 5 equals 5. This is false. Okay. Negative 6 cannot equal 8. That's really important that you see those differences. WTF is not the answer. WTF is what you're thinking. You got to go steps further down to get to the answer. And your thought process is, My x's dropped out, but this is false. That means there is no solution to this problem. No x in the world will make this true. Remember, x's, we're searching for truth. So this problem is no solution. And you should have run into a few of those on Mom over the weekend. Okay? Because it's no x's and false, this has no solution. There's no answer. But this problem is true. And this is a little bit deeper thinking here. This means all values make it true. In other words, pick a number, pick 7, x equals 7. If you plug it in here, it'll work. It'll check. Oh, but what if somebody says, I want x to be -3? And if they plug it in here, it'll check. Anything makes this problem true. Again, pay attention to the subtleties. The x's dropped out, but you ended up with a true statement. Okay, 5 equals 5. So that's true. That means everything makes this problem true. Everything. Not just one answer, a gazillion answers. So in order to embrace that, there's several different ways that we write the solution. Okay? And it all depends on what you want and what Mom wants. The fancy way is to write a capital scripted R, real fancy calligraphy R. Okay? Which stands for the set of all real numbers. Now, you could either put the fancy R or you can write the words. Okay? If you pick up an algebra text, they use this and this. However, a more modern algebra text will do this. Okay? Now that's interval notation. Remember we talked last week about interval notation. This says everything from -infinity all the way up to +infinity. Well, this is a math symbol for these words. Because these say everything. These words say the set of all real numbers. That's just a math symbol for that, and so is that. So all of these are the same. Lastly, the one I believe Mom uses is the word identity. Okay, identity means the left side is identical to the right side. They're identical to each other. Okay. In future math courses, you might end up using all 4 of these answers at different times, but they're all the same thing. It just kind of depends on what the instruction said. I'm pretty sure, and somebody can correct me, that most of Mom's questions said write identity or something like that if it's an identity. Okay. So with these 2 problems, what I wanted you to see is, number 1, we get to talk about the process of solving equations, get rid of parentheses, combined like terms, all that kind of junk. But these 2 were trick problems. The x's dropped out, okay? But this one was false, impossible, couldn't do it, so this one had no solution. This one was true, so that means everybody and their mother works. Everything makes it work. And so we have all of these terms, symbols, to say everything. Okay, one last thing, and then I'll open it up for a few questions for clarification. Guys, it didn't have to be 5 equals 5. It could be 7 equals 7, -2 equals -2. As long as these two are the same, it's true. It's not just 5 equals 5, 2 equals 2, 11 equals 11, 0.5 equals 0.5. And it's not just -6 and 8. It's anything that's not equal to each other. If I wrote 5 equals 7, that's impossible. Okay, it's not the numbers, it's what the numbers are trying to tell me. All right, I'll be quiet now. Questions?
Anytime it's a number on a number, same numbers are identical, it's true. But if it's any kind of number off, it's not false.
Assuming the x's all dropped out, yes.
Okay.
Yeah, now if you do another problem, okay, you do some other problem when we get x equals 3, well, that's just a normal problem. That's not one of these strict WTF ones. Okay. All right, anybody else? Okay, then let's erase and do 2 more.
Oh, I got a question.
Okay,
So what would you write in mom if there is no solution? It's the DNE thing or the,
is that what she says? Is that what the
Yeah.
instructions are? Then D and E. In mom,
Okay.
it's D and E. Most textbooks, okay, does not exist. I don't like that, but you kind of got to go with mom. The most common mathematicians just write no solution. Okay, but you need to get your grade, so just do what mom says. All right. So let's erase this one and then do. Okay, I'll get to that in a minute. So try these 2 problems. 1, 2. This is number 3. We're going to have 1/2 x plus 7/5 equals 3/5 x. Take away 1/2. And number 4, we're going to have a 2x plus a 3 over x minus 7 equals 2 over 5. So again, let's take a few minutes here. Okay. Each one of these was I'll call them a special equation, a trick equation, whatever. There weren't a lot of these in the mom work, but there was enough that you needed to see this. So this is a problem that had fractions in it. Okay, now there's a couple of ways to do this, but the way I was trying to show you the other day was to multiply everybody by the common denominator. So between 2, 5, 5, 2, what's the common denominator?
10.
10. So what you're going to tell yourself is I'm going to multiply this side by 10, and I'm going to multiply this side by 10. And now that's legit mathematics. As long as you multiply one side by one number, the other side by the same number, you're okay. We're going to distribute it in here. So we're going to have 10 over 1 times 1/2 x plus 10 over 1 times 7 over 5 equals, distributed in here, 10 over 1 times 3/5 x minus 10 over 1 times a half. Again, you don't have to show me that step, but you do have to think that step. You could do all of this on your calculator, and then the next answer, I should say, is after you go to your scratch paper and use your calculator, 10 over 1 times a half is 5x. Some of you can jump from this step to this step because you're good at fractions, or you just know that I'm going to do 10 times a half on my calculator and 10 times 7/5 on my calculator. That's okay. Okay, when you do 10 times 7/5, I believe you get 14. Okay, again, on your calculator, 10 times 7 over 1 times 5, that's 70 divided by 5, and it reduces to 14. Equals, over here, this becomes 6x. 10 times 3 is 30, divided by 5 is 6, minus, this is 5. Okay, any questions about what I've done? Where did I get the 10 from? How did I distribute it? And where did all these nice, pretty numbers come from? Any questions on that? Okay, so now this is now just a normal equation. Get x's on one side, ordinary numbers onto the other side. So I think personally, I'm going to take 5x away from this side. I'm going to get rid of this 5x, take 5x away here. That gives me 14 equals 1x minus 5. Add 5 because at this step you have all your x's on the right hand side. That means you want to move all your normal numbers to the other side. So you're going to add 5 to cancel that out. Add 5 to keep it balanced. So we get 19 equals x. Okay. And then technically, I won't take off for it, but it should belong into those funny braces. Those are called the truth set or the solution set. The truth set, 19, makes this problem true. When x is 19, it makes the problem true. Notice I just put the 19 in, not the x. Just the 19. The number 19 makes the problem true. Okay, any questions on this problem, number 3?
Yes,
Okay.
sir. One more question.
Yeah, go ahead,
Sorry.
shoot.
Like I said, I don't want to confuse anybody, but for example, sometimes in my mind I get mixed up. So you find the LCD,
Mhm.
and I forgot what that rule was, where you multiply the LCD that goes into like the top fraction, if I'm correct, and then like do the distributive. Sometimes I get them mixed up. Like for
Okay.
example, 1/2, like 2 goes into 10, right? 10 is the LCD.
Okay, that's a shortcut, but
Oh, okay.
you're right. Okay,
Yeah.
that's fine. What we're saying is taking, let's take this problem instead. It's more fun, okay? Let's take that one, 10 over 1 times 7 over 5. Okay?
Yeah.
Then the technical rule says do top times top, 10 times 7, bottom times bottom, 1 times 5, get 70 over 5, and then always attempt to reduce.
Right.
Okay, which is where we got 14 from.
Gotcha.
Now, that's, how do I want to say this? That's the straightforward, no tricks, traditional way to multiply fractions.
Okay.
Top times top, bottom times bottom, reduce your answer. An alternate way that some of you have been taught, same problem, is you've been taught something called cross cancel.
Yep. Yeah.
Okay. and you said, oh, look, 5 and 10 have something in common. And you said something like 5 goes into 5 once, 5 goes into 10 2 times. Something like that.
Yes, that's correct.
So,
Yes.
so now when you multiply across 2 times 7 over 1 times 1, you get 14 over 1, which is 14. You get the same answer.
Okay.
Okay, so, okay, from my point of view, I don't care how you got the 14. I don't care if you did it this way on your paper, or if you cross cancel this way, or if you actually put all this, it's a little bit slower actually to put this in your calculator. But if that's what you did here or wherever you did it, cool. As long as you got 14 for that problem, I don't care how. But this is the traditional way. This is the way, a slick trick way called cross canceling.
Perfect. Understood. Thank you so much.
Okay, yeah. Anybody else? Okay, now I know this problem could have been done at least one other way. But the technique of getting rid of the denominator, okay, finding the least common denominator, the LCD or whatever that thing is called, and distributing it, okay, is going to be really important. In fact, absolutely necessary when we get into chapters 8 and 9 later on. So I'm setting you up with this technique now. Now, if you found a different way to still get the same answer, it's okay. As long as it's legit math or algebra, I'll take it. But later on, you have to use this method. Problems just won't allow a different way of doing it. Okay, over here to this one. Now, I wish you hadn't asked the question about cross canceling. Okay, but you did, so whatever. This is called cross cancel because you're actually pre-reducing. You're reducing the 10 into 5 ahead of time. In this problem, we're going to do something called cross multiply. Different answer, different problem. Okay. Yes, they have the word cross in common. They both use the word cross, but they're totally different after that. So when we cross multiply, now you can only do it because this is called a proportion. A proportion is when you have one fraction equaling one fraction. If there's another fraction out here, like I said, +3 or something like that, you're screwed. You can't do it. But when it's one fraction equaling one fraction, you can use the cross multiply technique. And what that says is you multiply 5 times this, okay, and 2 times this. It doesn't matter. Well, as long as you go 2 times the bottom times top, you're going to be okay. So what I wrote is I like to go 5 parentheses 2x plus 3 because I want to make sure I'm going to go 5 times all of that equals, okay, this is going to be 2 times all of x minus 7. And it doesn't matter what side you put the 5 and the 2x plus 3. You could put it over here. And the 2 and the x minus 7 could have been over here. That'll all work out. It'll all work out just fine. But you had to make sure you did 5 times this numerator, all of it, 2 times this denominator, all of it. So if we distribute now, get rid of parentheses, okay, that's going to give us 10x plus 15 equals, it's going to be 2x minus 14. Again, distribute here. Okay. Much nicer, no more fractions. Okay, get the x's together. So I'm going to take away 2x from both sides. That's gonna give me 8. 10 take away 2 is 8x. Plus 15 equals negative 14. Take away 15, and this is where people, whoops, had some trouble. Okay, we have 8x. The 15's cross out, equals, this becomes negative 29. This says you lost $14 and you lost 15 more dollars. 29, stupid 29. It said 29 and I wrote 28. Good way to fry everybody's brain. Okay, divide both sides by 8. Always x has to be alone. When you're done, x is alone. So x equals negative 29 over 8, whatever that is. Doesn't go in nicely. Is that 3? No, it's not worth going in. So I would say my solution set is negative 29 over 8. Now, if you want to turn that into a mixed number, what is that? Negative 3 and 5/8. Cool. Or negative 3.675, I'm guessing. I don't know. Something like that. Anyway, my big concern on this problem was you use the cross multiply technique when you see one fraction equaling one fraction. Okay, the quickest way through this problem, again, there are other techniques, but the quickest way is to cross multiply. Bottom times top equals bottom times top. Okay, anybody? Any questions on that one? Okay, then we're going to get into new stuff. So let me erase the board. We'll get into new stuff. All right. One of the things in chapter 2, there's a lot I didn't get to last week. I didn't get to word problems. I didn't get to all kinds of stuff. But in chapter 2.7, we need to get to, we want to solve what's called an inequality. That means the problem will have less than, greater than, less than or equal, greater than or equal. Those are called inequality symbols, and we want to solve those. Now there's 2 types, okay? This is the one you're mostly used to, and then I'll show you another type. And there's a trick that you need to know. Okay, there's 2 tricks. Number 1, we want x on the left side. That's not, I don't want to say it's not a requirement, but it makes all of your answers so much easier. In an equation, remember an equation had an equal sign. In an equation, we didn't care if x was on the right side or x was on the left side. We didn't care. But for an inequality, it's safer to have x on the left-hand side. Okay, I'll explain that in a little bit. And number 2, if you multiply or divide, whoops, both sides by a negative number, you must flip the symbol, the inequality symbol. Now, I want to do the problems first, and then I'll try, if we have time, to show you why that rule occurs. Okay, it comes down to the study of truth again. Remember, mathematics is always worried about getting the true answer. Okay, we can never disrupt truth, unlike Republicans. Okay, we can't disrupt truth. So a simple problem, 5 minus 3x is less than 2x plus 7, something like this. And we did this last week. Okay, but I want to do it formally now. What we do in our brains is we pretend that that's an equal sign. And we say, what would I do if that were an equal sign? How would I attack the problem if that was an equal? Well, you'd say, I want to get all my x's on the left-hand side. All of my x's on the left-hand side. Remember what I said here. So I take away 2x from this side, take away it from here. So I end up with, whoops, why did I do that? That was stupid. Take away 2x. So I get 5, take away 5x is less than 7. Okay, now I've succeeded in moving all of my x's on the left-hand side, which means I want to move all my numbers, my normal numbers, to the other side. So to do that, I'm going to take away 5 from this side, because I want to get it out of here, but I have to keep it balanced, so I want to get it out of here. That gives me negative 5x is less than 2. Now's where the magic comes in. Okay, to get x alone, remember solving is always get x alone, somehow, some way. The only way to do that, okay, remember that's 5 times x, is to divide by negative 5. Okay, but because you divided both sides by a negative number, you have to flip the inequality over, have to. So this cancels out, we get x. Now, 2/5, if you want to call it negative 2/5, because you say, okay, look, 5 doesn't go into 2, so who cares? Or if you want to call it negative 0.4, I don't care. Doesn't matter to me, decimals or fractions. If you do 2 divided by 5 on your calculator, you get negative 0.4. I don't care. Okay, but this is important. Okay, because in this format with x on the left, the inequality symbol is always pointing in the way that you might shade. Now, mom might ask you to shade one time and she may not. I don't know. Okay, but shade, you start at negative 2/5. Okay, we shade, look at which way it's pointing to the right. So we shade to the right. And because it's not equal, we use an open circle. Okay. Okay, mom may ask you to put it in what's called interval notation. We talked a lot about that last week. Interval notation, okay, parentheses, negative 2/5, comma, infinity. Interval notation mimics what you see on the number line. You see I'm starting at negative 2/5 and I'm shading towards infinity. And that's exactly what interval notation is. So up here, this was called set notation. This is called interval notation. And It all depends on what the instructions say. I can guarantee that when we get to exam number 1, which is in a couple weeks, okay, some of my problems are going to say express your answer in set notation. Some of the problems are going to say express your answer in interval notation. So I'm expecting you to do both. If I don't say, then I don't care which way you use it. Okay, before I do another problem and erase these steps, any questions on that problem? No? Okay. So again, we talked about this last week. Now I'm just doing it in a more formal, it's part of section 2.7. Okay. We pretend that it's an equal. We ask ourselves, well, what would you do if it were an equal sign? And basically, you're following those 5 steps I gave you last week with 2 things. It's better if you put X on the left because then your symbol points in the direction you shade. Always. It's just safer that way. Okay. But the big rule is if you multiply or divide both sides by a negative number, which I did here, divide by -5, divide by -5, you had to flip the symbol over. Okay. So try, oh, this one. Oops, not red pen. This new example here. Let's go with 2x minus 3 is less than or equal to 4x plus 2 parentheses 3x plus 8. Okay, remember the rules: distribute to get rid of any parentheses, simplify each side separately, and then we're going to get x on the left. So I'll give you a few minutes to work on this problem. All right, let's see how far you guys got. So there's nothing to do on the left hand. It stays, whoops, 2x minus 3 less than or equal to. Now on the right side, we have the distributive. Okay, here we go. So we have 4x plus 6x plus 16. Okay. There are no fractions, but I could combine these, and that makes my work a little bit simpler. So I have a 2x minus 3 is less than or equal to 10x plus 16. Okay, just a little bit cleaner. I want my x's on the left, so we're going to take 10x away from both sides. Okay, that's going to give me negative 8x. Subtract 3 less or equal to 16. Since
Wait,
my
can you pause real quick? I want to
Sure.
write that down because I got that part wrong. Hang on one
Okay,
sec.
all right, I'll wait.
Okay, thank you.
Sure, no problem. We're
I minus, I guess I added 3. Yeah, I added 3 to get the 2 on the
that's
left
fine.
side.
I'm gonna add the 3 in a minute and get 19.
Okay, yeah. Okay, then go ahead.
Okay, I just like to move my x's first. That's just my personal hang up.
Okay, I like to save them for last.
Okay, and that's fine. Okay, as long as we end up with the same result. So
Okay.
I'm gonna add 3 to both sides. Okay, and I'm gonna get negative 8x is less than or equal to 19. So as long as you got that, I don't care. Okay, it doesn't matter to me how you did it. Again, it's not required, but it's safer for most students to have X on the left of an inequality symbol. Okay, I need to be honest with you. It's not a requirement, but it's safer. And by the way, set notation always ends with X on the left, so you may as well just do it anyway. Okay, so when they say set notation, X is always on the left automatically. So anyways, here, divide by -8. Divide by -8, okay? This gives me X. Okay, I divided, so I have to flip this over, greater than or equal, flip it. And this just stays -19/8. Now, because 8 doesn't go into that, it's not a pretty number. So I just say, screw it, 19/8. Remember we talked last week, in a fraction, you're allowed to move the negative sign from the bottom to the top to the middle. Okay, I need to erase this, but you can have -19/8. You can have -19/8. You can have opposite of 19/8. So you could have the negative sign on the bottom. You could have the negative sign on top, or you could put the negative sign right smack in the middle of the fraction. All of those are the same answer. If you pop all of those into your calculator and look at the decimal, they're all identical.
I got a question. So
Sure.
at what point is the inequality solved? Like which point? The
When-
very last?
When X is alone,
Okay.
okay? Well, a lot of it depends on the instructions also. But basically, when X is all by itself on the left-hand side, you solve the inequality,
Okay.
okay? What? My dog's looking at me. No, you have to wait a while. Okay. All right, now, I always go beyond solving because you never know what questions mom is going to ask. What if we graph this? What if mom says, graph the solution? Well, you've solved it algebraically. What would it look like on a number line? Well, on a number line, okay, somewhere out here, you'd have -19/8 negative. And because X is on the left, it's pointing in the direction you shade. So we shade this way. And because it said equal, X is greater than or equal to, we use a solid dot here. Okay. So that would be a fine graph. Usually people put 0 on it just for reference. They just show, hey, that's where 0 is. So that's negative something. Okay, so that algebra, X greater than or equal to -19/8, that number line graph are the same thing. Now, interval notation, because again, we never know what's going to be asked. We use bracket -19/8, comma, infinity. Okay, and you guys struggled last week. When do you use a bracket in interval notation? And when do you use parentheses? Okay, anybody remember?
When it's greater than or equal to, it's a bracket. If it's just greater than, then use the parenthesis.
Right, when it's not equal to, you use an open circle and a parenthesis. When it's not equal to, just greater than or less than, it doesn't matter. When it's greater than or less than, you use an open circle for the graph and a parenthesis for your interval notation. But if it says equal to, then you use a solid dot on the graph and you use a bracket. Again, that's a little bit review from what we did last week. I want to move on to some different problems. Still inequalities, but a little bit nastier. How we doing?
I had one other question. How would 19 over 8, would that be 2 3/8?
Yeah, negative 2 3/8. Yeah,
Yeah. All right, cool. I just want to make sure I was doing that right.
that's okay. Let's take a, I don't want to take a break, but do something different. Let's see if I can not screw this up, which I always do. Ah, can you guys all see my calculator?
Yeah.
Okay, cool. Let's let me turn it on. Okay. And let's do the 19 over 8. And I want to show you something. There are two fraction buttons here. Okay. There's this one, where to go? This one right here, which is just a plain old fraction. There's this one right here in blue, which is for a mixed number, like 2.5, 2 3/4. But I'm going to use this one here. And since it's its own button, I'm just going to press it. And notice what happens on the screen. Okay, it's waiting for me. It's going in and out of focus too, but it's waiting for me to enter something. So I'm going to go 19, arrow down 8. I'm not going to worry about the negative sign. Negative doesn't do anything. So I put 19 over 8. I think I did. Okay. Move off to the side. Okay. Now, there's a button right here. Okay, right underneath the plus sign, this silver button, right underneath the FD, this silver button. Okay. Well, actually, let's enter it first. Okay. And it says, my problem says, yeah, you dummy, it's 19 over 8. It doesn't simplify. But if I hit this button right under the FD key, see where it says FD, if I hit this, look what happened to it. It changed into a decimal. So the FD key right above this thing with the double arrows, it changes it forward and backward again, from fraction to decimal to fraction to decimal. So the FD key is kind of cool. Okay. I'll show you something else about this. Where's my square root? Oh, there it is. Okay, let's clear this all. Some of you guys remember, okay, square roots, okay? And something like, okay, the square root of 12, okay? Some of you have had intermediate algebra before, and maybe you remember, I'm going to put enter, that it simplifies into 2 times the square root of 3. Maybe you remember that, maybe you don't. It's okay, I'm going to teach it to you. But what if you want to know what's the decimal? Well, what is that as a decimal number? Well, down here again, this key right under the FD, okay, boom, it'll tell me what the decimal is. So this key right under the FD button, right there, that key switches from one format to another, from fraction to decimal or from square root to decimal, and switches back. So this FD key is kind of an important thing. Is that okay with everybody? Okay. Does everybody understand, let me clear it, how to input like 2 3/4? 2,
I think I got it.
2 3/4 like that. So it's right above the 7. Now this is a little bit trickier. Because it's in blue, you have to push the second 7. That's what will activate that key. because it's right above the 7, but it doesn't have its own keyboard. So we're going to go second 7. Now we want to input 2. Okay. And I said 3/4, 3 down 4. Move to the side, enter. Now look what it did for me. When I entered it, when I hit the enter key, it automatically turned it improper. But if I hit the FD key again down here, the FD, right, this one right here, boom, it'll tell me what the decimal was. Okay, and it'll keep going back and forth between decimal and fraction all over the place. Several people, okay, kind of screwed up on the quiz a little bit. And guys, you're allowed to use a scientific calculator. So what if you wanted to use 2 3/4 times 4 1/3? Okay, so you push second above the 7, and we're going to go 2 and 3, 4. Oh, I know. Do you want to add? Do you want to multiply? Do you want to divide? What do you want to do? Because it doesn't matter. Most people get all screwed up with subtracting. Let's do subtracting, okay? Because you got to get a common denominator. So let's do that. So we're going to go second 7 again to get that thing. And we want to do 4 1/3. 4 and 1/3. Move to the side. And now enter. And it automatically gives me the answer as an improper fraction, -19/12, but it found a common denominator. It found everything for me. And again, if you want to find it, the FD key down here, if you want to turn it into a decimal, great. Okay, you can. It's not worth it. So anyway, this calculator really has, all scientific calculators can do just what I showed you. And in my opinion, the Casio is a little bit simpler than this, but this has other features. Somebody started asking a question, I'm sorry.
Yeah, how do you input like a negative number?
Oh, okay, good question. Clear. Okay, cheated up. This key, look where I'm pointing, is a minus. Okay, don't do it. This key is a negative. So if you want to input -3, you input negative, come on. I hit, you can't see it on the keyboard. Shoot. Well, I hit the negative and a 3. Okay, and if I wanted to say plus -8, enter. I get -11. I lost $3. I lost $8 more, so I lost $11.
So how would you do it as a negative fraction? You do the negative with the, let's say it's a mix.
Oh,
with the
okay.
2, the 7.
What if we want to go -2 3/4 like that?
Yeah,
Okay, -2 3/4. Okay, cool, clear. So we want negative. So I hit this button down. Shoot, I can't see it on my. Can you guys see it on my keyboard?
yeah. Not now.
Oh, because the stupid
Yeah, now we can.
transcripts. Let me turn off. Oh, okay. So this negative right down here. So I want negative this fraction, second 7. Okay, so now I go 2, move over to the numerator, 3, move down to the denominator, 4th, move to the side. So it's negative. So I hit the negative symbol down here first, then I input the fraction. Is that okay? And if I just want to be weird, let's say divided by, I hit division, it gave me that. Divided by, let's say I want -4 1/3. Why is this thing going wacko? Oh, I know why, because every time my hand goes in there, it tries to focus on my hand instead of on the screen. Huh, damn it, okay. Negative second 7 fraction 4 and 1, I'll get my hand out of there, 3 arrow. So that's -2 3/4, this time divided by -4 1/3. And then I hit enter down here, boom. And it gave me my answer of, what is that, 33/52? Whatever, I mean, it's an ugly problem, but we don't have to worry about it. We just let the calculator deal with ugliness now. Anybody else, any other questions? Did that answer your question? I
Yeah.
tend to talk too much. So did I answer your question, and does anybody have any other questions?
Yeah, what mode is your calculator in? Like I have comp, stat, and table.
Left, everything on the left is highlighted. Oh, I'm in, what's that called? Math print
Print.
on the next menu down. Did you guys, did you see where I, clear.
No, I have a Casio.
Oh,
I don't even have a F to D button.
yeah, you do. It's there somewhere. It
S to
really,
D?
huh?
Is it S to D?
F2D?
No.
I
I
don't
don't
know.
have fractures to decimals. I have like an S to D, but
Try hitting that and see what happens.
yeah. I don't even know what mode my calculator is supposed to be in.
Okay, they have something called math print or pretty print. I'm sure. What model Casio do you have? 300?
Yeah.
It's got it there.
What?
It's got everything you're talking about. It really does. But we're probably going to have to wait until we get into the classroom together, and I can help you real quick. But
Okay.
it's there. If you go do a YouTube search, I don't know, fraction to decimal on Casio, whatever, 300, FX 300 or whatever in the world it's called.
Yeah.
Everything is on YouTube. You'll find somebody showing you how to do it. I promise you that. But it's there. And the only mode you want, the only mode that's important to us is it has to be degree. And if we come down here, this is in math print, and I'm almost certain the Casio has something called math print or something like it. But again, that's not critical. When we get together back in class, first thing you do is yell at me and get me, and I'll show you most of that stuff on the Casio. Okay?
Yep.
Yeah, don't panic. We'll get there. Okay, anybody else I can not answer? Okay, then let's drop this and go on to the next thing I wanted to do here. Whoops, didn't want to do that. Switch over to my that. When did I have a Casio? Wait a minute. Ouch. I have an FX 250 Casio, but you have a 300. You'd be amazed what people leave in the classroom. No. Actually, I have the calculator my daughter used in grade school. No, I don't have it at Casio 300. No, okay. Anyway, let's do this stuff. Go on. So these are known as, on the board, simple inequalities. Simple inequalities. What I'm going to show you next is called a compound inequality. Now, you know anything about like bone breaks? A compound break is multiple breaks. Something's a compound fracture, it broke the skin, it broke everything. Okay, it's a really bad one. Compound means more than one. So okay, compound. The easiest way to show you a compound inequality is to show it to you. Okay, this is called a compound inequality because it's one problem, but it's got the inequality symbol written twice. And it's actually, before you panic, it's actually really, really easy to do. Ooh, I do have a 300. I'll look at it. I just saw it. Okay. Okay, it's really easy to do. Super easy. Again, the question was asked, when you're doing an inequality, how do you know when you're done? When X is by itself. In this problem, we want to get the X alone. It's in the middle of the problem. We can't change that. Okay, but we want to get it by itself. So the first thing we're going to do is add 3 to all 3 sides. I know that makes no sense, but we want X to be alone, so we want to get rid of the 3. In the middle, then we have to balance it. We have to take 3 in the right, 3 in the left. Okay, so if we do this, we get -1. So that's equal to 2x, which is less than, in this case, 4. Now, we want to get x alone, but that's 2 times x. So here we go again. I have to divide this by 2, but I got to keep the whole sucker balanced. So
Why is it 4 when you
Yeah.
add the 3 to the 7?
because I'm an idiot. Thank you. Thank you. Thank you. Thank you. Okay. Thank you. So I divided everybody by 2. Okay. This is just ugly. This is -1/2, less than or equal to x, less than 5. Now, we're done because x is as alone as it can get in the middle. It's done. This was called set notation. Okay. If we wanted to graph it, look at what it's trying to tell us. It's literally saying x is in between -1/2 and 5. That's what it's trying to tell us. X is in between -1/2 and 5. So if we graph that, okay, we would shade. All of this shading represents x. Wherever we shade is x. That's all the x's. They're between -1/2 and 5. Okay, so what? We want an open circle on 5 and a solid circle on the -1/2 because of the equal and the not equals there. Okay, so that would be the graph. Last thing, you might be asked, I don't know, how do I put it in interval notation? Well, interval notation literally mimics the graph. So bracket, -1/2, comma 5, parenthesis. Closed circle or solid circle, I should say, bracket, open circle, parenthesis. And we're done.
Is it ever gonna come up with a compound where it would be like 3x greater than less 2 to 4, greater than less or whatever to 2x?
Yeah,
less,
but not in this class. And it gets a little bit trickier. You have to end up taking this thing apart and doing some weird logic stuff to it.
all
So
right,
yes, in about 4 semesters from now, 3 or 4, whatever, you'll get something that wacko, but 99% of them are just going to be like this for the rest of your math career.
okay. Thank you.
Yeah, good question. Anybody else? Any other questions? Okay, then you guys try. New problem. 4 is less than x over 2 plus 1, which is less than or equal to, oh, let's say 5. Solve it. Graph the answer and also show the answer in interval notation. Okay, so here we go. Absolute value equations. Now, this is an introduction, but when we're going to come back to this in chapter 9, we're going to do absolute value inequalities, and those get really, really messy. But their basis is what we're doing now. So what we're doing now, yes, it's going to be tested, but it's going to be expected that you know it by the time we get to chapter 9 again, because what we do in chapter 9 builds on this. Now, a couple things. First off, we talked last week, basically, what does the absolute value do to a number?
Makes it
Makes
positive.
it positive.
Makes it positive, okay? What if I had a positive number in there already?
Same.
Same thing, okay? That kind of boggles people, but that's really important. It doesn't matter whatever's inside the absolute value. It takes whatever's inside and expresses it as a positive answer outside. Okay, that's super important. So what if I had an algebra equation, not arithmetic? This is arithmetic, but this is algebra because it's got that x in there. Okay, this is saying what could x be so that the answer is 5? What could x be so that the answer is 5? X could be -5, because we know the absolute value of -5 is 5. Or x could be +5, because we know the absolute value of +5 is also 5. So when you see the answer is 5, the inside could have been 5 or -5. We don't know. It's both. So an absolute value equation always, 999 times out of 1,000, always has 2 answers. Always, because we don't know, we only know the answer was 5, we don't know what was inside. So we have to take both of them into account. Inside could have been positive, inside could have been negative. Okay, now everything that we're going to do that we're doing here is going to be based upon that idea. Okay, if the answer is positive, the inside could have been positive or negative. So let me do a simple problem here. Absolute value x plus 3 equals 7. Okay. If the answer is 7, then what could this quantity be worth? It could have been a 7. Because the absolute value of 7 is 7. But what else could this quantity have been worth?
-7.
-7, because we know the absolute value of -7 is 7. So because of that logic, that reasoning, we split this up into 2 equations. We say the inside junk could have been worth 7, or, and the or actually is important, although most students don't write it, or the inside junk could have been worth -7. We don't know. So we have to take everything into account. The inside quantity could have been worth 7, or the inside quantity could have been worth -7. We get 2 equations. We have to solve both of them. So take away 3, x is 4. Take away 3, x is -10. Again, I took 3 away from both sides of everybody. So now this problem has 2 answers, and it's really important that you don't just scatter them all over the page. It's really important that you bring them together into one solution set. Remember, this was called the solution set or the truth set. So you take all of these answers that x could be. It could have been 4, it could have been -10, and you bring them into one big answer. One single, where you put them together. Because you might have done some of your work over here, and you might have done some of your work over here, and I don't want to have to look all around for your answers. So you bring it all back together and say, this one thing is my answer. It includes the 4 from here and the -10 from here. But that's not the critical thing. The critical thing is that you take an absolute value symbol and it always splits into 2 parts. Okay, so let's have you guys try a problem and see how you do. Absolute value, 2x minus 5 equals, oh, let's say 15. Well, let's see how you do. Oh, that was stupid. Okay, so based upon what we did over here, we know we have to split it because it's absolute value, but we can't split it yet. We've got to get rid of the 3 and the -4. So based upon our discussion, we're going to take 3 away from both sides. That's going to leave -4 times that value 2x plus 4 equals -28. Okay. Then we're going to divide by -4 here to get rid of the 4, and we're going to divide by -4 here to keep it balanced. So that's going to give us the absolute value 2x plus 4 equals 7. Any questions to this point? Okay, so I isolated the absolute value quantity. It's all by itself now. Now I can do the splits. Okay, so what I think to myself is this quantity equals 7. So this could have been a 7, or this could have been a -7. So you write the two different equations. 2x plus 4 could have equaled the positive 7, or 2x plus 4 could have equaled the -7. Solving this problem, taking away 4 from both sides, I get 2x equals 3. Okay, take away 4, take away 4. Divide both sides by 2, I get x is 3 divided by 2. Again, you can leave it improper. Okay, you can turn it into 1.5, or you can turn it to 1.5. I don't care. Over here, take away 4 from both sides. Divide by 2 to get x by itself. Put them into one big giant solution answer. X could have been 3/2, comma, -11/2. The answer in solution set doesn't matter. It doesn't matter which way, who comes first or who comes second, as long as you got them both there. Questions? Okay, I didn't get quite as far as I wanted to get tonight. I was going to go into that worksheet. I guess I'm going to have to start tomorrow night with that. Okay, and we'll start chapter 4 tomorrow night. But I need 10 more minutes to do a little bit of chapter, where was it? It was 2.6. There was some weird stuff in chapter 2.6 that I haven't covered yet. So, with this, you should be able to do just about everything on the quiz, with 1 or 2 exceptions, which I'm going to show you right now. And I have a weird way tonight that I'm going to take roll, so please listen up.
So we don't have any homework due for the quiz, just the quiz, correct?
Just the quiz. The homework is due after the quiz, which is kind of silly, but I still want to give you time to do it.
Okay. We have till 11:59.
Huh?
You have till 11:59 or directly or right after
On the quiz or on
the homework to turn it all in?
on whichever night? I don't know what it says. What day is it? Monday is it, or I don't know.
You're talking about the quiz this Thursday, right?
The quiz is this Thursday, but the homework is due, I think, the following Monday, isn't it?
Yeah, Monday the 14th.
Yeah. Valentine's Day, yay.
That's our Valentine to you.
Yeah.
Like by midnight, right?
Pardon me?
Like it's due by midnight, 11:59.
Yeah, 11:59. Okay, so God, this is hard to erase. Muscles. In chapter 2. What would they say? 3, 4, 5. 2.6. Chapter 2.6. They talked about formulas and word problems, which I haven't talked about yet. Okay, now I sent you guys an email and I asked you to download the formula sheet, okay, and start memorizing those, at least the ones in the box. I know you can't see this, and I don't want to screw around with my document camera, but I don't remember. I gave you this sheet here, okay, with a bunch of formulas. Those are ones that you should know. Okay, now maybe not the quadratic formula, but everything else you should know by now. Those are fundamental to all of our math problems. I also asked you to print out a bunch of word problems. And again, I know you can't read this, but we're not going to get to it tonight. We're going to start these tomorrow. Okay.
I never got any of those. When did you send them?
Sunday, when I sent everybody a warning about the quiz that was due on Monday.
Okay, oh
I
man,
got several people emailed me back and said, thank you, thank you, thank you. So it went out Sunday morning, I think.
oh, it's okay. Yeah, I got it. I don't see any attachments on it.
No, I didn't put attachments. I just said they're in Canvas.
Oh, okay, cool.
Yeah, they're there in Canvas. So you can go to Canvas, you can find them. They're in the chapter 1-2 module. I think it says that in the email. Anyway, formulas. Okay. They're going to be doing all kinds of things, but one of the things they're going to be doing is, I'm going to call it resolving formulas. Okay, now that sounds weird. So let's say we take a basic formula, perimeter equals 2 times the length plus 2 times the width. Okay, and you'll see something in the directions. It may say solve for, oh, I don't know, W. See, this is solved for P because P is by itself. In algebra language, when we say solve for X, that means get X by itself. This is P is by itself, so this formula has been solved for P. The directions say, yeah, okay, fine. Take this formula, rearrange it, and get W by itself. That's what solve for implies. Get that, whatever that letter is, by itself. Okay, so what we're going to do is, in your mind, you pretend that these are other numbers. For example, instead of this, you think of this as 5 equals 7 plus 2W. So instead of this equation, I see this equation. Okay, I just made these numbers up, guys. The fact that I use 5 and 7, that doesn't matter. But I ask myself, okay, what would I do to this problem to start to get W by itself? Well, we've talked about it a couple times. You take 7 away from both sides. Okay, that's what we do to attack it. Take 7 away. Well, wait a minute. What over here was 7? Oh, it was a 2L. So we're going to take 2L away from both sides. Okay, so you come up with a simple problem and you ask yourself, what would I do in the simple problem? And you do a similar thing in this uglier problem. All right, but now here's where your brains kick in. Some of you, it's late at night, your brains are about dead anyway. Can you actually do P take away 2L? Can you in algebra actually physically do that? And the answer is no, because they're not like terms. But we write this, we say, I tried to take P take away 2L. I tried. But I knew, I was smart enough to know that they're not like terms. Okay, so I can't. So over here, we've got 5 take away 7 equals 2W. Okay, how do you get W alone? Well, you say, I would divide both sides by 2. I would divide this side by 2 and this side by 2. Well, you're gonna do the same thing here. Oh, this is a W, I'm sorry. This is a W. So to get W alone, I'm gonna divide this side by 2 and this entire side by 2, all of it. And then I get this answer, these cancel, so I have P minus 2L all over 2 equals W. And I have taken this problem and I have solved for W. I got W by itself. What I did was I made up a similar looking equation, asked myself, what do I do here? And I do something similar over here. So in section 2.6, you're going to get a bunch of formulas and they're going to say, rewrite them, solve for, and they may say the variable in red. Sometimes they're going to use colors, but they may tell you what to solve for. Let's try.
Could I write, for that one, could I write 1/2 P minus L equals W?
Yes. If you want to take this fraction apart, it's P over 2 minus 2L over 2. When you take it apart, the 2L, the two twosies cancel, and you wanted to write that as half P minus L. Yeah, that would be just as good. Okay. This is fine. And what you wrote tells me you attacked the problem a little bit differently than I did. But you got a legitimate algebra answer that's just as good as mine. So I give you full credit. Let's take another problem. A equals 1/2 BH. That's the area of a triangle. Okay. This is when we say 1/2 BH, we mean 1/2 times B times H. BH, 1/2 BH means this. This formula could also be written as A equals BH all divided by 2. Because think about this, if you do 8 divided by 2, that's the same thing as 1/2 times 8. They're exactly the same. The ultimate answer on the calculator is the same. So you can switch from one form to the other, whichever is easier for you. Okay, anyway, I want you to take either of these equations, I don't care which, and I want you to solve for B. Solve for B. That means I don't care which equation you use, get B by itself. Personally, I think that one's easier. The one on the far right. Okay. I said I thought this formula for this particular problem is actually easier. This has fractions in it. I hate fractions. So one of the things we learned was we said, hey, we can multiply both sides by 2. Okay, the common denominator was 2. So this is going to be 2A equals, this will become BH. Now, let me tell you why. Because if you multiply it by 2, this is like my scratch work over here. If I multiply it by 2, I get 2BH over 2. The two twosies cancel, I get that. Okay, remember when we did these with equations, the whole purpose of the LCD was to wipe out the denominator. So that's what I did. there's another way to do this, but we'll get this. Now I would need to get B by itself. I want B alone. That means I want to get rid of the H. So what's the H doing to the B? It's multiplying. The only way to get rid of that is to divide. Divide. Okay. So we go, I can't divide that. 2a over h, whoops, come on, dummy, over h equals, the h's cancel, I get b. Okay, that would be my answer, solving for b, so getting b alone. There are at least 3 different ways this problem can be done. I'm expecting, once you guys start looking in section 2.3, I'm expecting quite a few questions, either in class or during office hours before class, or maybe even after class. Because this is a really, it's not hard, but it's really awkward for students until you learn how to play the game. Okay, students just don't like it, doesn't make sense to them. All right, I want to get us out of here, so I'm just going to cut off questions. I do want to take roll, but it's weird tonight, so please listen up, everybody. Okay. Okay. On the quiz, on the mom quiz that you just took, okay, in problem number 11, okay, there is a place for a comment. Okay, I wrote like good job, or what planet are you on, or I wrote something, but I also wrote code equals, okay, and I put some animal. Now, every single one of you got a different code, okay, of some form, some kind of animal. What I want you to do tonight is I want you to email me, okay, in the subject line, your animal. Okay, now I've written them down. I know who has which animal. I wrote them down as I gave you the code. So you're going to have to go to mom. You're going to have to look in your quiz, click on it, look in your quiz, scan down to number 11, and in the comment, okay, I wrote an animal. So you email me back just real quick in the subject line what your animal was. Okay, zebra, yak, whatever it was on yours. I've got them written down over here. Okay, you have until midnight tonight.
Okay, and is this the mom input quiz?
Yep, that's the only quiz you've taken in mom. Yes, the mom input quiz.
Oh god, I don't even know how to find the
See,
answer.
you got plenty of time to go find it. Just go to mom. Okay, go search on that quiz. Go into chapter 1 where the quiz was. You can click on it, and it'll open it up for you.
Yeah, is it so I have a spot where it says practice, showing as practice now?
Right. So you can open it up and do it.
Oh, okay.
Okay, and you go down and you should find your code. Go down to number 11. And do you see I made a comment?
I don't see any comment.
Did you do number 11?
Number 11 is the area shade.
Yeah.
Yeah, but I don't see an animal in there.
I don't have a comment either.
Yes,
Guys,
I-
go to the grades section
Oh,
and you will see feedback.
To the what?
Grades.
go to grades.
Oh, great.
Huh, I found it the other way the other day.
Wait, so it's grade book and then what?
Yeah, and then click on your quiz.
My quiz doesn't even show on here. I did do it.
It's on the bottom and you can see feedback.
Oh. Okay, cool.
Wow.
That was, alrighty.
Okay, got it.
Wait a minute, say it again, because it worked differently for me as the instructor.
So you go to grade book
Yeah,
and then you scroll all the way down for some reason, the mom input quiz is on the very bottom. And then from there, in the bottom right corner of I guess the grid or the table rather, the bottom right corner, it says view feedback, and then that's where it just pops up for you right there.
because mine is totally different. I guess it's because I'm the instructor and not. Shoot, okay. All right, well, did everybody follow that? Go to grades,
Yeah.
scroll down, you'll see comments. And let's go to course. Oh. All right, I gotta make myself a dummy pattern, or whatever. Email me your animal. We'll see what's happening.